Okay, so we're going to continue working in Chapter 8. Our last section there discussed final tests in this section, and we've done a lot of testing. This is Chapter 8 here. A lot of testing of hypotheses that depend on one parameter. Population proportion, population mean. There was a couple cases. Really, only one of them that you're going to use in practice. One of them was sigma is known, and the other one is sigma is unknown. This is the one that we worked on the other day. Today we're going to work on testing a claim about a standard deviation. Now, one thing about testing this claim is that before you even do the hypothesis test, you have to do another test to make sure that your data is normally distributed. Now, unlike our tests of population means, where the central limit theorem tends to hide all our sins, we have to be really, really careful with population standard deviation. It has to come from something that's a normal distribution. So we'll start out with an example where we test that. That's going to be our assumption going in. Now, the overall test has this format, and it's the same basic 6 steps that we've been doing for our other tests. State your null and alternative hypothesis, decide on the level alpha. If you're doing it old school, what you would do is you would find some critical values in the tails of a chi-square distribution. Now, that chi-square distribution is going to have n minus 1 degrees of freedom, where n is your sample size. Not shown here is the two-tail test, but it's essentially the same. If you're, again, doing it old school, then you would compute a test statistic with these degrees of freedom and compare your critical value here, or compare the test statistic to the critical values and decide, are you going to reject or fail to reject? If you're using StatDisk, then what you should do at this step would be find a p-value. Find a p-value, and then use that p-value to decide if you're going to accept or reject. And this is the nice thing about using a statistics package. You don't really have to get your hands dirty in terms of finding the critical values in these distributions. And just look at the p-value. The p-value should tell you what you need. Fail to reject or reject, and then state your conclusion in words. So we'll start with problem number 10, which is measurements from a random selection of females. We've got that loaded in StatDisk, and we're going to focus on their pulse rates. Problem number 10 says to use this data to test a claim that for a sample of 40 women, that the standard deviation of their pulse rates is 10 beats per minute. So we're going to test the claim that sigma is equal to 10. So sigma is equal to 10. Is that going to be part of our null or alternative hypothesis? Has to be part of the null. Has the equality. So h sub 0, let's put that in there. What has to go in the alternative then? Good, sigma is not equal to 10. So there's a quick 3 points for you on an exam. You stated the null and alternative hypothesis correctly, and you used a parameter here as opposed to using S. You should not be using your sample statistics in stating the null and alternative hypothesis. In order to do this test, we need to make sure that the data come from a normal distribution. So here's the nice thing about StatDisk, so we can do that pretty quickly. So, trying to remember where its normality test is under data. So you go to data and then down to normality assessment. So let's click that. Data, normality assessment. We want that for column 2, which is the pulse rates. And let's click evaluate. Now we don't know too much about this, but we can certainly read the output. It says fail to reject normality with a 5% significance level, fail to reject it at the 1% significance level. Take a look at the data. Doesn't look too bad in terms of a normal distribution. And the quantile plot looks pretty good. And finally, and rather objectively, failed to reject the null hypothesis that we had a normal distribution. So what that's saying is that we can proceed with our test of the population standard deviation. Okay, so let's close this. We're good with that. And let's do the analysis part now. So go to analysis, hypothesis testing, and then down to standard deviation, 1 sample. Level of significance we want to do this one at was 0.05. Claim standard deviation is 10. And we're going to use the data. So click use data. Our data is in column 2. So click use data. Data is in column 2, and then evaluate. Now you get a lot of output here. What's the one thing that we're looking for this stage? P-value. All right, so we got a p-value of 0.1575. 1575. So Ryan, what's that telling me that I should do with my null hypothesis then? P-value is 0.1575. I got a 5% significance level. Reject or fail to reject? Do we agree? Fail to reject. You reject it if it's lower than the significance level. So, the mantra is if the p-value is low, h naught must go. So it's only when it's really small, lower than our significance level, that you're going to reject. So fail to reject h naught. Now we need to state our conclusion in words. Let's see if I can't dig out that handout for us. Okay. So one of the things that's probably helpful for you to do is, when you're doing these problems, write down what the original claim is. The original claim here, in this case, was that sigma is equal to 10 for the standard deviation. So that original claim contains the possibility of equality. So we're here. Did you reject? No. So we're down to here. There is not sufficient evidence to warrant rejection of the claim that the standard deviation of pulse rates of women is 10. I'd be uncomfortable saying that there is sufficient evidence to support the claim, Because the way you set up your hypothesis test is that you're assuming that the null hypothesis is true. And I'm not really comfortable saying we support it when we started out by assuming it was true to begin with. So I'd rather say that we didn't find enough evidence to reject it. So the standard deviation of pulse rates is equal to 10. Okay. Appreciate the question though, Chris. Thank you. Anything else for problem number 10 here? Okay, let's try one more here. Problem number 14. Oops. Listed below are speeds in miles per hour measured from the southbound traffic on I-280 near Cupertino, California, based on data from SIG-Alert. The simple random sample was obtained at 3:30 p.m. on a weekday. Use a 5% confidence level to test a claim of the highway engineer that the standard deviation of speeds is equal to 5 miles per hour. Okay, so let's enter this data into StatDisk. So I can close this out and we can clear out the data that we have here. So let's just clear that. Yes, I do want it cleared. And let's enter in some data. 62, 61, 61 again, 57, 61, 54, 59, 58, 59, 69, 60, and 67. Let's set up and conduct a hypothesis test for this one. What's the claim that we're testing? Cool. Standard deviation of speeds is equal to 5 miles per hour. So is that going to belong in our null or alternative hypothesis? Null hypothesis. Keegan, what's the alternative then? Yeah, not equal to 5. Now you're not saying what it is, you're just saying it's different than 5. That's all you're saying. We're going to test this at the 5% significance level. Alpha equals 0.05. We're going to do this on StatDisk. What do you think I should do next? Ooh, bonus points here. Well done. Let's test and see if this looks like it's from a normal distribution. Now, the data set here is so small, they could probably just get away with anything and say, oh, yeah, it's normal. Yeah. But let's go through the test anyways. So that test, again, was underneath data, down to normality assessment. I'd be surprised to be able to reject with such a small data set. So the data is in column 1. Evaluate. Well, it actually doesn't look too bad as far as the histogram or the normal quantile plot. And the bottom line here is that fail to reject the normality assumption at the 5% and the 1% significance level. So, okay, it looks reasonable that we can proceed with our chi-square test. So we've got our data in. Let's clear this one out. We checked our assumption. So we checked normality. Now let's do the actual analysis part of it. So analysis down to hypothesis testing, and then over to standard deviation, one sample. %5 significance level. Claim standard deviation is going to be 5. And again, use data. We don't have summary statistics, although depending on the problem, you could do it with summary statistics. The data is already in column 1, so when it's all set here, oh, one thing we should check, and fortunately it's already done for us, is the form of your alternative hypothesis. Now, I'm not sure if it always defaults to 1, but this is the actual one we need. The alternative hypothesis is that standard deviation is different than the claimed standard deviation, or different than 5. So with the correct alternative hypothesis, let's click evaluate. So in this case, we get a p-value of 0.4525. Carlene, should I accept, or I would fail to reject, or reject the null hypothesis? Good. Fail to reject. So we'll fail to reject H naught. And last but not least, again, we've got to word our conclusion. I think we're going to be doing more or less the same thing as we did with the last one. I think I wrote problem 12, but is this 14 or is it 12? It's 14. Yeah, it's 14. See if you can't correctly word your conclusion. All right. Someone want to give that a shot? How would you state that? Yeah. Perfect. Pretty much exactly what I wrote. There's not sufficient evidence to reject the claim that the standard deviation of highway speeds is equal to 5 miles per hour. Let's follow that up with one last little detail regarding this problem, and that is the confidence interval. Now, the nice thing about StatDisk is that it gives you the confidence interval. So let's take a look back at our output here. And our confidence interval, we actually have two. One's for the variance, and one's for the standard deviation. The problem with using the variance is that the units there would be in miles per hour squared, which it's kind of a strange unit. So we're much more comfortable using this one, standard deviation. So the standard deviation is somewhere between 2.89 and 6.92 miles per hour. So let's write that down for ourselves. The 98% confidence interval is 2.89 less than sigma is less than, what else is it, 6.92? How does that compare to our conclusion from our hypothesis test? Are we kind of concluding the same thing? Yeah, because 5 miles an hour is in this range. That's where we think it is. So we're not going to want to reject the possibility that sigma equals 5 miles an hour when we think that that really could be one of the true values. So this does match it. In words, you could say we can be 98% confident that the true standard deviation of highway speeds is between 2.89 and 6.92 miles per hour. So, again, yes. I think it's 90. You know what? 98%. Let's just take a look back here. No, it's 95%. My bad. All right, so 95% confidence interval, which is good because we did a 5% significance level. All right. So